Section 5.2. Mixing the alphabet. Simple substitution requires a mixed alphabet. There are several traditional paper and pencil methods for this. One way to obtain a mixed alphabet is to use a keyword. In the simplest case, you just write the keyword starting at some position and then fill in the rest of the alphabet behind it, wrapping around as needed. The remaining letters can be filled in forward or backward. Here are 3 examples. This method was first used by the Argenti family, who were cipher secretaries to several popes and bishops circa 1600. These alphabets are not well mixed. A somewhat better method is to use 2 keywords, like this. Columnar mixing. Write the alphabet into a block. Write the keyword on the top row and the rest of the alphabet in as many rows as needed. Longer keywords give better mixing. Then read the letters out of the block, going down the columns. In this example, the keyword sample has been written on the top row. The first column reading downwards is SBIRY. The second column is ACJTZ, and so forth. If you like, you can alternate reading up and down the columns, or use other routes. Skip mix. When I was in high school, I invented another method suitable for paper and pencil cryptography, which I call skip mix. It uses a string of small numbers called skips as a key for mixing the alphabet, for example 3, 1, 4. Begin with the standard alphabet, skip 3 letters and take the next letter, which is D. Delete that letter, then skip 1 letter and take the next letter, which is F. Delete that letter, then skip 4 letters and take the next letter, which is K. Then repeat the 3, 1, 4 cycle. Skip 3 letters and take the next letter, which is O. Continue to repeat the cycle of key numbers until all 26 letters have been chosen. The resulting mixed alphabet is. Skip mix can be used with a keyword. Suppose the keyword is sample. Replace each letter by its position in the alphabet, in this case 19, 1, 13, 16, 12, 5. Optionally, replace any 2-digit number by its individual digits, in this case 1, 9, 1, 1, 3, 1, 6, 1, 2, 5. Use this string of skips as the mixing key. Note that 0 is a valid value to use. Skip mix is well suited for computer use. In this case, the alphabet is the 256 different 8-bit character codes. The skips can be any integers from 0 to 255. The numeric key still can be derived from a keyword. The advantage of using a keyword rather than just a string of integers is that it is easier for a person to remember and to type accurately. Suppose again that the keyword is sample. The numerical equivalents of these letters in ASCII code are 83, 65, 77, 80, 76 and 69. These values fall in a narrow range from 65 to 90, which gives less thorough mixing. To spread the letter codes over a wider range, they can be multiplied by some constant value, modulo 256. The multiplier can be any odd number between 7 and 39 inclusive. For example, the ASCII codes for the keyword sample multiplied by 17 modulo 256 are 131, 81, 29, 80, 12 and 149. This covers a range of 149 minus 12 equals 137, much wider than the original range of 83 minus 65 equals 18. There are still only 26 possible values for the skips. One way to obtain a larger set of values is to multiply adjacent numbers modulo 256. The sequence of skips would then be 83 times 65, 65 times 77, 77 times 80, 80 times 76, 76 times 69, and 69 times 83, all taken modulo 256. So, 83 times 65 equals 5,395, which is congruent to 19, mod 256. The numeric key becomes 19, 141, 16, 192, 124, 95, covering a range of 192 minus 16, which equals 176. Another way to produce a larger set of values for the skips is to multiply the first letter of the keyword by 7, the second letter by 9, the third letter by 11, and so forth, with all multiplications done modulo 256. Since the conversion of the keyword into the numeric key would be done with the computer, not the human operator, an arbitrarily complex calculation could be used. I recommend a quadratic function rather than a linear function to make it harder for opponents to deduce the keyword if they obtain the plain text of some messages. For example, if Ni are the terms of the numeric key and Ki are the numeric values of the characters in the keyword, then a suitable function might be where the subscripts wrap around when they exceed the length of the keyword. For example, if the keyword had 10 characters, then K11 would wrap around to K1, K12 would wrap around to K2, and so forth. The function Ki plus 1 plus Ki plus 2, Ki plus 3 would not be as strong. If the length of the keyword was L, then there would be only L distinct quadratic terms. Emily could treat these as L variables and solve the set of L linear equations to find the values of the L products K1, K2, K2, K3, K3, K4, KL, K1. It is then easy to find the values of the individual Ki. Throughout this book I show alphabets mixed with simple keywords so that you can see at a glance how they are formed. For example, the alphabet. This is very weak. Do not do this in practice. I have done it here to aid the reader. Since you do not wish to aid your opponent, always use well-mixed alphabets using columnar mixing, skip mix, or some other strong mixing function. See section 12.3.8 for other methods.